Thank you so much for joining for the first public Hydrilla information session of 2023. I recognize many folks who are here today, but for those of you who I haven't met, my name is Liz Kreidinger, and I'm the steward and executive director of the Cayuga Lake Watershed Network. We are a 25-year-old nonprofit organization, and simply put, our mission is to advocate for the health of Cayuga Lake and its watershed in a changing world. So these changes come in many forms, including but not limited to pollution and invasive species. And in order to meet those challenges, we need a network of individuals, institutions, and communities united in the protection of our region's water resources for the ecosystem and for the use and enjoyment of generations to come. So towards those goals, our work includes three important tasks: science-backed education, engagement, and advocacy, and the first two are critical for the latter. For that reason, the Cayuga Lake Watershed Network has been involved in community engagement and education related to invasive hydrilla on our lake since it was first found here in 2011. And over the years, we've organized teams of volunteers to survey the shorelines for early detection, published over 50 articles, press releases, and newsletters on the subject, run radio ads, social media campaigns, managed lakeside information boxes, and held stakeholder engagement meetings like today's pre-season session. So each year, we update our Hydrilla Action and Information webpage with the latest links and documents with current information, from presentation slides to treatment plans to county water quality testing results for the herbicides used for hydrilla management. So our local programs are designed to keep the community informed and engaged in the management of hydrilla in Cayuga Lake, because it really does take a network with lots of organization, people, and resources to keep this aggressive plant from spreading further. And this is why there is need for widespread collaboration and resources, and why the Cayuga Lake Hydrilla Task Force was created and has grown over the last decade. All these stakeholders work together to implement the hydrilla management plan for Cayuga Lake. And today, you'll be hearing from speakers from several of those agencies. First, we'll hear from Sam Beck-Anderson. Sam is the Associate Director of Invasive Species Programs and Coordinator of the Finger Lakes Partnership for Regional Invasive Species Management. Sam will be giving you an overview of the role of the PRISM in hydrilla management, the history of hydrilla work on Cayuga Lake, and the importance of prioritizing prevention and regional invasive species management. After Sam, we'll hear from Richard Ruby, who is a fisheries biologist with the U.S. Army Corps of Engineers. Rich will provide an overview of the Corps' role in control activities on Cayuga Lake and 2023 plans. And then we'll hear from Mike Robinson, who is the DEC Region 7 Aquatic Invasive Species Coordinator. Mike will be updating us on the role of the DEC in hydrilla management. To keep this session running smoothly, everyone is welcome to submit questions during the talks through the chat, and I'll be able to circle back to those and you during the discussion at the end. To keep it moving forward, I also ask that you keep your microphones muted during today's presentations, except for at the end when we invite questions during the Q&A time. And so with that, I will hand it over to Sam.
All right, great. Thank you, Liz. I'm just going to share my screen here. Just a second. Okay. All right. Can you see my screen?
Looks good, Sam.
Wonderful. All right. Thanks, everybody. I'm glad to be here. Thanks, everybody, for joining us. And thanks to Liz and the Cayuga Lake Watershed Network for hosting this great event. Like Liz mentioned, I am Sam Beck-Anderson from the Finger Lakes PRISM, and I'll be giving the 10,000-foot overview of this project and efforts over the years, and then kind of talking again, like Liz said, about our role. So just to give a little bit of background about who we are, the Finger Lakes Institute is a department of Hobart and William Smith colleges that's focused on contaminants, nutrients, watershed management, and of course, invasive species, all problems that affect the Finger Lakes watershed. Our mission is really to take information, research, and science, and kind of turning it into actionable versions of what we're trying to go for. So collecting data and doing research on a smaller scale or larger regional scale, then kind of making actionable moves with that to improve the water quality and protect the water quality and resources of the Finger Lakes. The Finger Lakes Partnership for Regional Invasive Species Management is a program hosted by the Finger Lakes Institute. New York State is broken into 7 prisms throughout the state. Each prism is hosted by a specific institution, ours, of course, being Hobart and William Smith colleges. The concept of prisms are a network of state, federal, local NGOs, and other stakeholders. These networks really support diverse and really comprehensive and interdisciplinary approaches to invasive species management that take in a number of different viewpoints, stakeholder priorities, and other kind of general aspects, and allow groups focused on similar goals of invasive species management to leverage, limited resources available for these types of programs within the region. Funding through the Finger Lakes Prism is through the New York State Environmental Protection Fund and is administered by the New York State Department of Environmental Conservation. So just kind of thinking about where we are here in the Finger Lakes region, I think the regional geographic context is really important. Obviously, we are in a really large area within our prism, so we're 17 counties. We're the largest prism in the state. But where we are located, I think, has a lot of really interesting connectivity issues that make the problem of invasive species, and specifically hydrilla, specifically challenging. The Finger Lakes is obviously a large geographic region that's easily accessible and is frequently accessed. It is one of the top tourism areas in the region. Of course, many people on this call will know the abundant resources in tourism and agriculture that are held here at the Finger Lakes, and of course, the fisheries are not to be excluded from that tourism economy. So the hydrologic connectivity is also really important. So the Finger Lakes are connected physically to the Great Lakes through Lake Ontario by way of the Seneca and Oswego rivers. Everything flows north, eventually getting to the Seneca River and draining into Lake Ontario. But also the Finger Lakes are connected to a number of other areas, in a way that's not exactly physical, more of a theoretical connection between the massive amount of boat traffic and recreation that occurs throughout the region. This is a map that shows the connectivity between a number of Cayuga Lake and then Hydrilla specifically and the rest of the area. So from there, we want to talk a little bit about what invasive species are. Generally, an invasive species is non-native to a habitat under consideration, and it causes some type of harm to a habitat or a community surrounding a habitat, whether that's economic, environmental, or human health. I think where we are here talking about hydrilla and Cayuga Lake, there are a lot of different versions of these impacts that hydrilla could be causing to our region specifically. But again, those connections that we are kind of trying to focus on as well. So the connections to the Great Lakes, connections to other parts of the New York State and within the Finger Lakes themselves. Invasive species management kind of generally follows this invasive species curve is a very commonly used tool to describe how management is approached in terms of invasive species. As time goes on and an invasion increases in size, the management tactics and goals and strategies is meant to and should be adapted in order to get the most effective per unit resource put into a management effort. So at the beginning, before invasive species is present, where you're really focused on prevention. This is the most affordable and most valuable method of management of an invasive species that an area can do, in basically avoiding the species from getting there in the first place. So where I think we are generally with hydrilla is still at this point is there have been evolutions and increases in infestation area over time, but not to the point where where the concept of eradication has totally been lost on us. So we are still in this area where we have the best chance of managing it. So we could go back to where we are focused on prevention theoretically in some of these areas. And that is essentially where we're at. As time goes on, of course, you do start to worry about just containment and ultimately about asset-based protection and long-term management. So at a certain point, these invasions get to a point where you're really not even worried about preventing or eradicating or containing populations like zebra mussels can very quickly extend beyond the point of that, where those management options are valuable, to the point where you're really just focusing on retaining what you already have and managing the assets that are being affected by it. So the plant of the hour, I guess, hydrilla. This is a invasive macrophyte, of course, with a broad habitat range. It can become established in a number of different habitats, from slow-moving water, of course, to where we know of open water. As well, it can grow to up to around 30 feet is deep for it, but can grow up to 20 feet deep very, very easily. In our region, we are dealing with monoecious hydrilla, of course, versus the dioecious version of hydrilla. This plant spreads by fragments, seeds, and tubers and turions, and is essentially a very effective plant at coming in and disrupting native habitats and really creating a monoculture in many areas, and generally disrupting food webs in wherever it happens to become established. So when we're talking about hydrilla, we're going back to that concept of, where are we at in actual management of hydrilla. We're really still focused on prevention in many ways. This is one of we'll talk, as we go, we'll talk about active management as Rich and Mike and myself kind of continue to have this conversation about where we're at. I do want to point out kind of the prevention activities that have been occurring consistently throughout the Finger Lakes with the concern of the hydrilla and Cayuga Lake. These come in the form of watercraft steward programs, basically inspectors at public boat launches that are looking for plants like hydrilla, and making sure that boaters aren't carrying those plants in between, unaffected and infected water bodies. We're also, partaking in a great deal of education and outreach and early detection through surveys throughout the region, and specifically on Cayuga Lake, of course. So getting a little bit into the kind of history of hydrilla on Cayuga Lake. This is just a quick graphic of the different known locations and populations of hydrilla on the site. You can sort of see at the bottom here, 2011 initial populations found by the public, the floating classroom. Additional populations found through surveys. And as we go, we continue to see a general trend of kind of seeing that, it's not just, us that are, the professionals that are finding hydrilla. In many cases, it's the public and people kind of just interested in knowing about hydrilla, through whatever means that they've become familiar with it. They're looking at, how these, we can see how this has changed over time. So a general spread northward within Cayuga Lake, with some kind of skipping around throughout the lake. So starting down in 2011 in Ithaca, the next larger population found in Aurora, additional populations found in 2018 and 2019 in King Ferry and Lansing, most recently on the east side. Eastern Shore, and then most recently this past year we discovered, or a member of the public once again discovered, population at Sheldrake Point. So what ultimately, so my slides are out of order here, but ultimately going back to kind of the economic impact of hydrilla, I think, is really important. Kind of why is this an important plant to manage? I think this is also just generally invasive species going back to there are the obvious, for the conservation side of things, the obvious impacts that hydrilla can have, threatening native plant species and fisheries, and water quality as well, but also kind of bridging into that the human element of the impacts that this plant can have. So impacts to actual recreation, transportation, water control, infrastructure, all of those things can be quantified, in some cases even have been quantified by groups like the Great Lakes Great Lakes Council of Governors have, had these massive, have predicted these massive economic impacts to the region. Obviously, that is a massive region when we're talking about the Great Lakes Basin, but it goes to show that there are a number of different ways that a plant like hydrilla can have specific economic impacts to things like recreation, beach use, commercial navigation, water supply, and recreational fishing and ag. Comparisons to Florida and South Carolina in the past, and past analysis of this have shown that New York, if unchecked, New York could be facing, management costs and treatment costs up to $10 million annually statewide. So these impacts are out there, and they are, of course, significant. This is an overview of how the populations on Cayuga Lake have evolved over time. So blue, you have sites that where hydrilla was sampled or surveyed for and was not found. Orange, you're seeing where hydrilla was actually detected, and gray is our cells where our sites where the site has not been sampled yet. So you can kind of see that over time, our understanding of hydrilla on Cayuga Lake has changed. The expansion of this site expansion has changed over time, and the management strategies have changed as well. So as you go through here, you can see the S stands for survey, C for chemical treatment, M for mechanical treatment. Even within a site, the amount and types of different treatments have evolved over time to kind of bring us down to where we are today in 2022, where we still have several sites that have active hydrilla populations, and only a few that have been actually managed that still are fully, have not been identified. But it is, of course, and Rich will get into kind of I believe the reduction in biomass, things like that. So to say that we are unsuccessful where we're still finding hydrilla, I think is totally an oversight. The amount specifically that's, even though, like I said, so basically, even though there's a lot of oranges still on this in 2022, we are still working towards, a very specific, effective management strategy where we're seeing some success in a lot of areas. The stakeholders have also kind of changed over time. Obviously, thinking about the local impacts are really important to the people that live here, but also the more broad stakeholders, I think, are meant to be celebrated and kind of highlighted here as well. So, of course, Cayuga Lake Watershed Network. This group on the left is essentially the start of the local hydrilla task force. It started at the south end of the lake over a number of years. The Hydrilla Local Task Force has remained a unifying, consistent participant in gathering folks and ideas and efforts, and focusing efforts for hydrilla and Cayuga Lake. But over time, of course, the involvement of different groups such as the DEC, the Army Corps, and the Finger Lakes Institute and PRISM have evolved as the problem has evolved, as the problem with hydrilla has evolved over time. I think this really starts to point to kind of where we're at right now with the Cayuga Lake Hydrilla Management Plan. This was published by the Cayuga Lake Hydrilla Task Force in 2021. And this is a really comprehensive look at where we should be going lake-wide that I think really encapsulates a lot of the priorities that are held by, the stakeholders that we just talked about, but also, the people on the ground, the folks that are interested, that live on the lake, people that fish on the lake. All of these different priorities and values are being taken into account when a document like this is created and followed. What this document does is makes clear a certain path that should be taken in terms of everything from outreach to the actual treatment, to containment, and kind of shifting plans and shifting management techniques to reflect a true adaptive management approach to hydrilla for the years between 2021 and 2026. There's a lot of also really helpful resources. This is available publicly. There's a lot of helpful resources for outreach and education and coordination that are consistently used by a number of stakeholders throughout the region. So thinking about this adaptive management, I think is really important, and really is a focus of, I think, what we want to communicate today, and also what is actually being practiced throughout the lake. So this idea of, we're not just kind of setting and forgetting a management process. We are continually collecting data, analyzing that data, evaluating the results of a specific treatment of outreach, or anything from outreach to chemical management, and reevaluating our goals, priorities, and actually how we uphold and kind of go after and approach those goals. So I think a really good example of this is kind of in our camp for the Finger Lakes Institute. We are fine-tuning detection. We are trying to branch out a little bit from the typical macrophyte rake toss surveys and trying to incorporate more visual surveys through scuba and snorkel. I know the DEC is engaging in some of this work as well. We're going to be focusing mostly on Cayuga Lake, but also a little bit on some other water bodies, just making sure that hydrilla is being, we know about any hydrilla populations as we go. So speaking, I know I'm a little bit over time, but just to wrap up here, plans for the Finger Lakes Prism for 2023. We'll be continuing rake toss surveys on Cayuga Lake and common transient boater destinations from Cayuga Lake. So areas like Owasco Lake, Atisco Lake, Seneca, of course, Canandaigua Lake. We see hundreds of trips that are coming directly from Cayuga Lake and are traveling to these other sites. We are focusing on marinas, boat launches, and other access sites within those regions to ensure and help us, ensure that we can identify and detect early on and rapidly respond to any new treatments. We will also be monitoring treatment sites weekly in King Ferry and Lansing on the east shore of the lake, in addition to supporting Army Corps and DEC surveys and monitoring where needed between Aurora and the South End, and really wherever is needed. We're all really working really closely together on this project, which is a wonderful thing. Like I said, we're also going to be conducting dive surveys on Cayuga, Owasco, and Canandaigua Lakes. And we're also have pending contracts to do an additional hydrilla treatment, chemical treatment, again, permits pending, but planning on working with Solitude in Lansing. And we will also have additional watercraft stewards on Cayuga Lake as well. And again, I know I'm a little bit over, but just kind of some parting thoughts, kind of going back and hitting on that idea of adaptive management and kind of working the amount of expertise that is involved with this group of partners that's been focused on this, going back to the beginning with the local hydrilla task force, and now today involving really everybody from around the lake, is a really good example of adaptive management. And I think it's very well reflected in the communication, detection and monitoring and treatment. And you can see kind of, if you look closely at some of these projects and how these efforts have changed over time, you can see that we are really focused. It's not a one size fits all process. And we're really trying to focus on effectively managing this responsibly and comprehensively. So we'll be happy to answer any questions after the chat. Sorry, again, I went a little over time. Thanks, Liz.
Thanks so much, Sam. Next, we'll be hearing from Rich Ruby from the Army Corps of Engineers. Just as a reminder, I am keeping track of the questions and comments added to the chat, and we'll be ready to loop back to those after the presentations. All right, that looks good, Rich. You're on mute. That's the last thing I'll ask you to do.
There we go. Okay.
We're not looking at this slide now. Something got switched.
No, I had to switch in order to turn the.
Yeah, classic.
I'm
okay,
not working on
very
multiple. Oh, okay.
Looks good.
So thank you everybody for taking some time out of your day to actually participate in this. This is a project that we've been at least involved in Cayuga Lake, either peripherally or directly. 2011, some individuals from our Engineering Research Development Center helped with the first detection of Hydrilla in Ithaca, and they were technical experts helping with the original treatments that were done. And then in 2016, when the new Hydrilla infestation in Aurora was discovered, we were asked to come out and to start helping. So I'd like to at least acknowledge some of my collaborators from the Army Corps. Mike Greer, who was the original project manager and has since moved up, and he's actually now the program manager that runs all the ANS research and aquatic plant control research programs from our Engineering Research Development Center. Myself, I'm a fisheries biologist, and I've been involved in this since we've been involved in 2016 in Cayuga Lake, and then also when we moved down and started working in Ithaca as well. Mike Voorhees is another biologist at the Corps that works with me. He's kind of my backup on Cayuga Lake, and we also have a control program in Erie Canal that he heads up. And he has recently become our project manager. So Mike will be much more involved in this as well for the future. So the overall goal of our program, which is a research and development, it's looking at unique and ways in order to actually, I don't know why that's actually timed that way, to look at different ways to apply these herbicides and potentially other techniques that can be used to control hydrilla in these really difficult to treat areas, which can be heavily mixed areas like these littoral zones and these larger lake systems, also flowing systems like the canals and some of the lower tributaries where we've been finding hydrilla as well. So the overall goal is to basically make sure that public safety is always number one, that we're using responsible use of well understood herbicides if we are using chemical treatments in order to go after hydrilla and try to eradicate it. We obviously are interested in protecting and restoring the Great Lakes and Finger Lakes and the associated ecological and economic benefits of those regions. There's a lot of concern about hydrilla and the potential impacts it can have to the ecology as well as the economy with regards to impacts to different things that Sam touched on. And then also, obviously, to significantly reduce the risk of hydrilla spreading and potentially eradicate it in the actual area itself. So we know it's in Cayuga Lake. Cayuga Lake is on the Erie Canal system. Outlets into that, and the biggest concern that we have is trying to contain it where it is and make sure it doesn't spread into that area, because once it hits that location, it can it could spread to other areas of of the state with the connections that the Erie Canal has, and the fact that that actually is also acts as sometimes water and tributary into other systems. So it can greatly spread throughout the lake system, or excuse me, the state system. So before we start talking about the chemical treatments, I think it's important to touch on the overall different types of options that we had. Sam talked about integrated management, and that's part of the big things that we are always looking at. What are the ways that we can actually try to control this plant? Hydrilla is very difficult with a difficult plant to control, and it has some definite issues when it comes to certain other controls that can be used for other types of plants. And that grass carp has been used effectively in smaller systems and in reservoirs in that where you don't have as much of a large system. You also it's not an open system like we currently have with Cayuga Lake. But the problem with grass carp is that they're not selective. They're not going to just eat hydrilla. As a matter of fact, hydrilla is not one of the most palatable plants. It is used by waterfowl and by herbivorous fish, but there are other native plants that are out there that are much more palatable and would be consumed by if we were to use something like grass carp. Plus the number of grass carp we would have to utilize in order to take down just the hydrilla, and unfortunately, it would also impact the other native plants, which we also have benefits for. Having a good plant community is a healthy ecosystem as well. Mechanical harvesting, I know, is something that is oftentimes used for control of aquatic plants. Unfortunately, hand pulling, suction dredging, harvesting, any of those types of techniques, oftentimes it actually, because of the ability of hydrilla to be able to grow from fragments vegetatively and to spread very quickly, oftentimes after harvesting, the hydrilla actually comes back and is even denser in that area than it was previously. And we're talking only weeks after the cuttings because of the incredibly fast growth rates that hydrilla has. It's probably one of the faster growing aquatic plants we have, with each little fragment of that plant growing up to 1 inch a day during the peak of the growing season. So you can have one individual plant, if you were to count all of the different pieces of that plant, with the way this plant branches out as it grows up to the surface, they've documented up to like 190 inches of growth in one day by one plant. So you can see how the growth rate that this has is just very dramatic. So by cutting that down and giving it kind of a haircut, it just promotes that actually increasing that growth back, as well as all those fragments that are now created, potentially growing new plants and just expanding that. In addition to that, mechanical harvesting actually has been documented with also impacting the fish communities in those areas, because it's not selective. It will take in smaller fish and that in with the harvested aquatic plants, and there's been documentation of about a 30% reduction in some areas of the fish community as a result of the harvesting activity. So environmental extremes, I know there's a lot of questions about, because Cayuga Lake is farther north, and why would, is this going to really be a problem as it is in some other areas? Sam talked about the fact we have monoecious hydrilla here, then there's dioecious. Loosely explained, the monoecious hydrilla it grows throughout the growing season and then it dies off in the wintertime back to those potato-like tubers, or these other vegetative structures called pterions, which are basically, they can overwinter as that, and then they can start growing from them the next year. They build up these tubers over time, and those tuber banks can be very difficult. They don't always all sprout at the same time. So that's the monoecious hydrilla. That's the hydrilla we generally get in the northern climates from North Carolina north up into there. That's the type of hydrilla we have. If you're looking farther south, you're looking at dioecious hydrilla, which is a more tropical environment. It actually grows all year long. It does not die completely back to just a tuber. It actually, in the wintertime, it does reduce some of its biomass, but it basically stays as a growing plant, or as a plant above the water or the sediment surface. So the fact that we know that that our climate temperatures are in some areas increasing, in the long term, the potential spread of this plant could potentially, the excellent growing conditions can extend farther north. So the belief is that the range of the suitable range of hydrilla is probably going to go even farther north. And actually, just looking at the ranges of suitable habitat for them, it expands all the way up into Canada. So even though we're in the farther north, we still have a long enough growing season, especially with how adaptive this plant is and its ability to grow, to have large, dense populations of hydrilla if this is not managed and goes unchecked. And once you get to those large amounts, that's where you can start seeing those other detrimental impacts to water quality and potentially some other impacts to some of the other aquatic wildlife, as well as recreation for boating and swimming and those types of things. Selective biocontrols. Those would be looking for other animals that just selectively feed on hydrilla. They have been testing some on dioecious hydrilla. They're looking for some for monoecious hydrilla. There's nothing that has yet been put out yet for that. I know they're studying it, but right now the monoecious hydrilla, because it dies back completely into a tuber underneath the sediment, there's not enough plant there for at least some of the biocontrols that they've been looking at and testing for the dioecious control hydrilla. Then there's the other option is just, if you're not going to apply herbicides, you're not going to use grass carp, mechanical harvesting, you're in an area where unfortunately the environmental extremes are not really going to take the plant out, and selective biocontrols to work, we could do nothing. If we do nothing in this case, that is a management option. The unfortunate thing is that hydrilla is one of the most unique invasive plants, which is why it's so to most individuals, it's very concerning to them that the impacts that this potential plant could have, because it can grow in lower light conditions, it can grow in lower water temperature conditions, it can also grow in deeper conditions than other plants, and it can basically muscle out our native plant populations. It can grow to the surface, it can actually cause, once it gets to that level, it can change the water quality, it can have a lot of impacts. It's been demonstrated to impact flood control areas and actually increase flooding as a result of clogging of those particular areas. So there are some potentially large impacts that could happen if it goes unchecked. So because of that, and most of the issues we have with that, with those other types of control methods, the herbicides in some cases, especially certain types of herbicides, are some of the most successful and valued control methods for using for going after hydrilla. In this particular area, because of the location
Looks
If
like
you guys
we
want- yeah, I was
had
gonna
a
say, if you guys want, I
Rich
can
freeze.
just start my section and see if Rich comes
Okay.
back.
Rich, if you can hear us, we're gonna skip forward to Mike's presentation and we'll loop back to the herbicide slide when we've got you.
Although, am I gonna be able to share my screen if he's still sharing his screen?
Yeah, I can I can do that. Here you
Frozen
go.
in time.
Here we go. Thanks for your patience, everyone. Of course, this happens sometimes with the
Technical difficulties.
remote sessions.
All right, I am sharing my screen. now. All right, did my screen pop up?
Yep, yeah, if you could just go into slide share presentation mode, be great.
Mhm.
We're looking at
All right.
we're looking at the notes version of that, Mike.
Oh, okay. I don't have any notes, so.
That's all right. I think just the straight PowerPoint screen had the slides looked bigger at least.
Hopefully this one. Or are you still looking at the notes version?
No, that looks good. Thank you.
All right. Thanks everyone for being here today. My name is Mike Robinson. I'm the Aquatic Invasive Species Coordinator in DEC's Region 7. I'm just going to start off here by giving a little overview. Of course, there we go. Okay, so, you know, the DEC has been involved in this effort in more of a guidance and funding approach since early in the project, but 2022 was the first year, just last year was the first year that we were boots on the ground on this Cayuga Lake project. My position as the Regional Aquatic Invasive Coordinator just started last year, and that came along with a seasonal 4-person strike team. That was essentially to add capacity on a regional level to try to kind of tie in central office in Albany to more regional needs in each of the regions, but I'm specifically focused on DEC's Region 7, which includes Cayuga Lake. So as far as added capacity to Cayuga Lake itself, you know, an additional 4 to 5 people, we were able to add additional point intercept surveys and tuber and snorkeling surveys. We were also overseeing a couple subcontractors. We had Solitude Lake Management doing our treatment and water sampling, and we had Northeast Aquatic Research doing any, well, an additional point intercept and tuber surveys focused on the South Lake near Ithaca. So I'm just I'll try to keep mine brief so that we can get to the questions part. But anyways, this is just an overview of our 2023 field plans. We're going to be continuing to treat in the southern section of Aurora, which is divided north to south with the Army Corps on the northern half and the DEC overseeing the southern half of that. Sheldrake and Wyers Point area is new this year due to hydrilla detections last year. Both of those will have supplemental water sampling or supporting water sampling. We will continue and expand upon our point intercept surveys that we did last year, as well as continue the tuber bank monitoring we did last year. And we're also trying to add additional supplemental survey efforts with added scuba, snorkel, and pilot testing and underwater drone, which will hopefully have the same effect as a scuba survey. So here's our results from just the DEC portion of the Aurora area. The large blue polygon, biggest polygon there, that's the monitoring area. The smaller areas within that were the treatment areas. And you can see that all those red dots, as well as the yellow ones on the bottom, are where we detected hydrilla within that large blue monitoring area. You'll notice that most of the dots fall within the treatment area. That's where we expected to find it, which is why we were treating those areas. And then we found a little bit on the northern edge that was, you know, outside of the treatment area. And then we also found those yellow ones at the bottom. I just marked them in a different color because they were found post-treatment season. So they were found in about October or early November at the very end of the season. And that those yellow dots are right in the Long Point State Park boat launch there. Again, this slide just shows the areas that we treated, as well as the areas that we collected water samples for that treatment in 2022. Our treatment schedule is basically mirrors what the Corps has been doing the last several years. So it's a 10-week low-dose treatment going from late June to early September, starting first couple of weeks at 20 parts per billion, and then the following 8 weeks. So it's basically a once-a-week treatment, because you're trying to maintain a very low concentration, because this Sonar H4C with the active ingredient of fluridone, it's a systemic herbicide, so it's being uptaken by the plant, as opposed to a contact herbicide where, you know, you might think of something like Roundup, more of like a contact herbicide. Similar to Harpoon is used sparingly. The only area that we treated with Harpoon last year was this red polygon up at the top. That was the same area that we found the hydrilla that was slightly outside of our treatment area, and we just wanted to, because we found it mid-season and it didn't get the full treatment that the rest of the area did, we chose to hit it with Harpoon at the very end of the season, and that was, again, 3.3 acres of area that was treated with Harpoon. That entire area is about 125 acres. 2023 plans look almost identical to 2022 plans, except with the inclusion of that polygon at the top, as well as the polygon in the Long Point State Park boat launch. Treatment schedule is the same, spot treatment with Harpoon as needed. Here are this was new in 2022, so hydrilla had not been detected at Sheldrake prior, despite monitoring efforts for several years leading up to 2022. You'll see that so initially right at Sheldrake Point there, a recreational scuba diver reported hydrilla. Finger Lakes Prism and DC went out to confirm it. We continued to sample up and down the shoreline from there. We found additional points, as you can see, spread between Sheldrake and Wyers Points. That's the north and south extent of what we found. We continued to survey about a mile north and a mile south of those northern and southernmost extremes, and didn't find any additional. So this all happened at the very end of the year. We were sampling. This survey basically took place the first week of November. So we had already finished our season at that point, but then that hydrilla was reported and we mobilized and went back out there. That area where it looks like there's sample points missing in the middle, that's just because the Finger Lakes Prism sampled that area, and I only grabbed the one hydrilla point that they found from that, as opposed to the green just represents everywhere where we took a sample, and the red is where we actually found hydrilla. So it's not that there's a data gap, it's just that it was a different agency that did that section. So this is what a potential treatment plan would look like for this year. You see, we tried to be very conservative with the treatment and just draw smaller polygons around the known points of hydrilla. There's also one little polygon in there that doesn't have a hydrilla point in it. That's mainly for permitting purposes, because we're basically trying to build in like that little 10-acre one that's called Central Treatment Area on the bottom there, and you see there's no hydrilla point in there. That's essentially we have to permit for it now, so that if we do find additional hydrilla in there, we'll have some flexibility and work with the permitting office to shift the polygon to where the actual hydrilla is found. So without that, we're basically looking at a 20-acre treatment that is just honed in right around the known hydrilla areas. And then that larger polygon that's kind of a sandy looking color, that is the calculated dilution zone. we end up notifying, we send out letters to everyone within that, the shore lake, or, you know, the residents of the shoreline there. And then this is where we would be taking our water samples. You can see that 2 of our water samples are half-mile north and half-mile south of the northernmost and southernmost extent. And that is where we should be, you know, detecting any fluoridone in the water at less than, you know, basically non-detect, so less than 1 part per billion. Oh, it looks like Rich is back now too. These are additional areas which largely was developed through identifying high priority areas. Most of those high priority areas are marina boat launches, as you know, one of the main modes of invasive species moving around is hitchhiking on boats. So that's why we focus on those areas. The yellow one on top, that's Aurora. The orange one below that is Sheldrake. And then you have a handful of other marinas or launches below that. And additional ones that are, if you don't see them on my map, it's because these are just the ones that the DEC is going to perform this year. You know, my strike team of 4. And the other ones will largely be covered by Finger Lakes Prism. Additional efforts we do out there, here's us doing some tuber sampling at tuber sampling sites in the south end of Cayuga Lake. We also do a larger South Lake point intercept survey, which you'll see on the next slide. These points represent a kind of long-term data set that was started back in the day with Racine Johnson, aquatic ecologist. We've tried to keep that going as resources allow. You know, that being so that we do have a long-term data set, which looks at both, you know, efficacy of the herbicide treatment itself, as well as just kind of tracking the plant community over time so that we can see that we're not, you know, losing biodiversity or having any, you know, unplanned impacts like large patches of, you know, where there's nothing. And the data that we have collected over the years seems to support that idea that, you know, we're not wiping out the biodiversity of the plant community that was there before treatment started, and we're also not leaving massive voids where there's no vegetation. And then those green points you see on there are the five historic tuber sampling locations that we've continued, well, last year and this year we plan to do it again. That's just because, I don't know if Rich or Sam mentioned the banks, you know, a major mode of reproduction is that they put down these tubers, and those tubers can be viable for 5 to 7 years or so. And so we're tracking that over time to show that we, you know, are depleting the seed bank essentially. Because, you know, if you stop the program before these seed banks are depleted, even though you're not seeing any growth above the benthic layer there, you know, it's just going to pop back up from that seed bank. Here are our planned scuba sites. You'll notice that they're focusing on the northern part of the lake where hydrilla has yet to be found. So, you know, because in Sam's presentation, you noticed that he mentioned that it has kind of been trending northward. You know, the lake flows northward. So we're jump ahead and get some underwater. I mean, we already do some rake tosses up here, but we're trying to expand, supplement those underwater methods, which, you know, underwater methods such as snorkel and scuba can't cover an area, the rake tosses, but they can see what's there at a finer scale. So essentially the combination of those methods together will hopefully increase the ability to detect hydrilla even when it's in low density. So there's our 8 or 9. We're probably going to eliminate one of these points because we're only paying for up to 8 surveys, but that's a subcontract we'll have this year. And hopefully we don't find any new additional hydrilla, but that's why we're doing it. And then we're pilot testing this year. We're hoping that it will have a similar ability as a scuba team. Obviously, it's going to have long-term, it's much cheaper than hiring for scuba. Although, you know, it has some additional limitations. Obviously, a person underwater is going to have the best chance of finding very small infestations of hydrilla. But as I said, this is a much more cost-effective long-term solution. But this will be the first year we're testing it out. So this is a pilot year. And as I mentioned, we're going to be supplementing the existing rake toss areas with a subsection using this. And we'll see how it works this year and if it's worth it. Just kind of wrapping up real quick. You know, this was meant to be at the end of the presentation, but I imagine everyone in this room is here because you know, we all value this precious resource that are the Finger Lakes. You know, New York is very fortunate to be home to the Finger Lakes and have such a beautiful area. You know, we all got into this field because we are passionate about natural resource management and maintaining biodiversity. You know, not only is this a economical issue, it's also a recreational and economic issue. You know, we have to try to balance the needs of all lake users as well as the environment itself. So, you know, by maintaining biodiversity, we're also, you know, keeping the fisheries going, and we're also keeping economic values of properties around the lake from, as opposed to if they got overtaken by large masses of topped out hydrilla everywhere. You know, if the entire littoral zone of, you know, say the 0 to 25 feet around the perimeter of the lake became a solid monoculture of hydrilla, not only is it wiping out a lot of biodiversity, but it's making it difficult to swim and fish and boat and recreate. And yes, you can still use the deep middle of the lake for that recreational activity. But you know, it has the potential to have severe impacts to all of those areas. And of course, you know, we're out there doing this effort, but it really is it takes a community, because it really only takes, you know, one person to create a new infestation, whether it's someone dumping out an aquarium that they're no longer interested in that had some exotic plants in it, or someone driving through a patch of hydrilla and then transporting it to a different part of the lake. We really all need to work together and be vigilant to try to stop the spread. And with that, I will kick it back over to Rich Ruby.
Thanks, Mike.
I'm just going to stop sharing the screen. There we go.
Okay. I believe this is where you lost me.
That's right. Yeah, if you could restart on that slide. Thanks much.
Yeah, that's not a problem. I apologize. I didn't realize I was going to have technical difficulties like this. So just getting back to this, the types of herbicides that we are using, out here for the majority of the treatments, the larger scale treatments that we're doing is Sonar H4C, which is a systemic herbicide. It's actually an herbicide that disrupts the plant's ability to make food, and it takes exposure to the plants. It takes about 45 days or more for the plants to actually begin to die off and reduce back. Because of that, it's excellent in the fact that it doesn't cause large die-offs of plants all at once, and that can cause impacts to water quality and dissolved oxygen, like can happen with other types of herbicides on large scale, very dense applications. And we generally use this herbicide also because it's been demonstrated to be safe it's safe to use and approved by both the EPA as well as by New York State for around potable water intakes. And we do have potable water intakes at Wells College. We also have some that are used by the locals at their camps and that. So we actually make sure that we utilize an herbicide that is safe to use at the levels that are allowed to be used. And in this particular case, we're actually applying at no greater than 20 parts per billion. So we're actually applying less than what the water quality and a lot of the other statuses are with regards to that. We're trying to maintain a 3 to 5 part per billion level by doing those weekly treatments. We do treatments over about an 8 to 10 week period in order to try to maintain that 3 to 5 parts per billion for that 45 to 60 days or so if we can, to get that to get the desired impact on hydrilla. We're also using a lower dose, which is selective for hydrilla and some of the other plants, so that we don't impact all of the community in those areas. And we actually do monitoring both pre and post. And although we do see a reduction in the amount of plants in the areas that we're treating, we still have a good diversity of different plants, both natives as well as some of the other invasive plants that are out there that are not as susceptible to the to sonar, but we're really just targeting hydrilla and trying to reduce any potential impacts to the other ones. The other thing that I'll note is we do weekly water quality testing. We also test the potable water intakes, and throughout the years that we've been treating from 2016 in Aurora and from 2017, 2018 down in Ithaca, we have had no detects in all the potable water intakes to this point. So even though we've been applying for the last several years in these areas, we have not had any even detections of sonar, even though it's safe. There are no restrictions to swimming. There are no restrictions to fishing and eating the fish at the levels that are 150 parts per billion, but we're down in the 20 part per billion and less. And like I said, we're not even detecting levels in the Wells College potable water intake. At the beach, we do beach samplings to make sure we're not exceeding anything. And then in this coming year, we're actually going to add an additional area that has a potable water intake as well. So we do monitor, and with the reason we're using these particular herbicides are because they're safe to be used in and around potable water intakes. Harpoon is a chelated copper. It's a fast-acting contact herbicide, and that is used. The only time that we will use that is for spot treatments. These are areas where either they're outside of the treatment areas, and it's an area that is still early enough in the growing season that we think we can apply it and potentially kill the hydrilla in that area, and also to make sure that it's not in and around those, even though it's safe to use around those potable water intakes. We definitely try to make sure that we just are doing small treatments, because this isn't as selective. This is also will kill algae. It will kill a wider range of plants. So we try to make sure that when we're using this, we're using it in very pinpoint areas and much smaller areas that we're treating. Last year we didn't even use it in Aurora. I don't think and in Ithaca we did use it in one area, and that was Cornell Crew Bay. That just because we had a little bit of the hydrilla in there that didn't seem to be being affected as much from our Sonar H4C treatment. So we actually applied copper, but there are no potable water intakes at all in the Cayuga Inlet area. So So getting to Ithaca, that is the one location that we've been treating there since 2018. The last year we've been treating there for the past several years. Hydrilla was found in areas along Stewart Park, up near the Cayuga Sailing Club, also over by Treeman State Park in some areas there, as well as some areas down in the Cayuga Inlet. Last year we treated approximately 90 acres of area. The good news is that 90 acres that were treated, we did not see any hydrilla after the August timeframe. So we saw hydrilla earlier in the year, really concentrated in the Cayuga Inlet area is the only place where we really saw it last year emerge. And then we actually continued to monitor, and in October we did not see any. So we had a very successful treatment last year. As a result, this upcoming year, we are actually concentrating our efforts in the Fall Creek and Cayuga Inlet and pulling back the herbicide that we used here. So this year, we're actually looking at potentially doing only 70 acres of herbicide application concentrated in these areas. The other thing is as I said, we do monitor the both the responsive plants outside in the area as well as inside the treatment areas. And although we do see a reduction in biomass inside the treatment areas, which you would expect because we're applying the herbicide, we still have a good diversity of plants there. And some of the native plants that are actually there aren't impacted that much and do pretty well. White stem is one, Elodea. So there are some different pond weeds and some native plants that actually do pretty well with where the hydrilla is actually getting damaged as a result. And we've noticed this annually. It's one of the reasons we use the lower doses, as we've tried to be as selective as possible, concentrating on those areas, not just by shrinking the areas to only include those areas where we've been finding hydrilla for the past couple of years because of that tuber bank that Michael talked about, trying to exhaust that. But at the same token, we're also using lower levels of herbicide that are at levels that are effective against hydrilla, but trying not to affect as many other plants in that, and also do a safe application for every other concern. This year, you can see where we've pulled back the treatment areas to just the areas where we found hydrilla in the past few years. This is Fall Creek. This is an area where we're actually using a liquid version of sonar that's injected here. And then we do the sonar H4C, which is the pelletized version of sonar within the rest of the areas, concentrating on either areas where we've had hydrilla, or in this case, immediately downstream where some potential fragments are, and there's boat slips here. So the whole idea is just trying to keep the hydrilla out of the areas where it potentially can either be spread or could get rooted in and have some issues there. As I mentioned, because of the systemic nature with which this herbicide works, we apply usually over an 8 to 10 week period. And in this case, we're using it in Fall Creek. We're using both the liquid and the pelletized form, whereas the rest were not. So I'm going to skip ahead so we can save some time. In addition, as I mentioned, we do water monitoring at all of the locations where we apply herbicide. And in this particular case, after the herbicide is applied, 24 to 48 hours after, we take a sample. So that should be the highest levels that we see for the treatment. The pellets are a slow release pellet, so it's going to release the most off, and then it's going to tail off over time. The state requires us to actually do monitoring within a half mile outside of our treatment areas, just to make sure that the herbicide is not extending any further. And and as I said, in the years that we've done this, we have not had any above detection limits here, so we haven't exceeded anything. But we do notify all individuals that are property owners within this half mile area around the treatment area, as well as we put signage up at any public areas that like Stewart Park, Treatment Street Park, we have signage that's along that. We also have signage along the creek and the inlet, just to notify people that there is an application if they're not a property owner, but they're a public user of the public space. I'm moving up to Aurora. In Aurora, last year we applied about 70 acres. We treated approximately 70 acres, basically from Wells College Bay, extending north up the shoreline. We had a very effective treatment for the areas where we actually put the herbicide. The issues that we found is that on the edges of those, we still did find some hydrilla patches in the October sampling. There also was some hydrilla that was found farther north, which I'll talk about in just a minute. The percent occurrence of hydrilla, though, in the area, even though we are finding it, is much lower than we originally found when we started treating here in Aurora. When we first started treating, we were finding it in 50% of the points we had and lower, and now we're finding it in less than 1% for the past several years. So we've had some effective control within the treatment areas, but we still have a good frequency and occurrence of native submerged aquatic vegetation, sago pondweed, some of the other pond weeds, as well as Elodea, Vallisneria. They're all still part of the community and actually still doing well in this area, as evidenced by the number of fishermen and people that recreate in this area. There still is a pretty good native vegetation in this area. As we said, we did find additional hydrilla patches last year. This is a result of Finger Lakes Prism and New York State DEC, as well as us, doing some additional, there were some dive surveys, point intercepts, and just looking for the plant. So it did extend another about 2 miles up the shoreline now to Great Gully Cove Road up in this area. And as a result, the applications that we're proposing to do this year actually will extend up into this area. And our monitoring of this entire area is going to go from the 438 acres it was last year to 735 acres. So this is this year's proposed treatment area. You can see down here, this is DEC's area that Michael already talked about. And what we have is Wells College Bay, and this extends all the way up to over to past our Great Gully Cove area, road area. We are just selecting or trying to use areas where the hydrilla was found within the past couple years, and not treat any additional areas than that at this particular point in time. Let's see here. So if we look at the northern treatment, this is going to be just a standard 10-week treatment, 20 parts for the first 2 weeks, and then the rest to put us at the maximum amount that we're allowed by the state, which is 150 parts per billion seasonally. This is a similar treatment that we've been doing for since 2016 and the areas along here. We have pulled this away from the shoreline more. We are allowed to actually treat in less than 2 feet of water based on the state's special use of for treating hydrilla and using sonar in this area, but we are pulling this aside because we haven't been finding it in that really shallow area, and just treating the areas that where we've been finding hydrilla, which is a couple feet all the way out to 15 to 20 feet of water. So the southern treatment that we have here, we have this divided into two, a shallow and a deeper treatment. Shallow treatment is 12 feet or less. The deeper treatment is actually 12 to 18 foot of depth, or 12 to 20 feet, where we are finding it in those deeper areas because of the clarity of Cayuga Lake. It just, hydrilla can grow in those deeper areas to begin with. Here we're doing, instead of 10 weeks, we're doing 8-week treatment. The first 4 weeks we're doing a 20 part per billion, and then 10 part to maintain that 3 to 5. This area is a little heavier, doesn't get as much mixing as the more northern areas, but it still gets more mixing than the deeper areas that are just a little bit deeper, have a little bit less mixing and flow from those. As a result, we're using a much lower treatment here, only 10 parts per billion for the first 4 weeks and then 8.75. So the whole idea is to get an effective treatment on Hydrilla using the least amount of herbicide that we have to do in order to do that. Again, same as what you saw down in Ithaca, we're doing weekly water treatments, and we're also coordinated with the county health department. They'll be doing collections weekly of the Wells College water utility, also at the swimming beach, and then also Mackenzie Childs has a potable water intake as well. And we'll be taking water samples, weekly water samples, having them analyzed. All of the data that we collect weekly is actually coordinated with and sent to all partner agencies as well as the county health department and put up on the health department's website. So the public can just check the website and they can see what the current values are with regards to the all of the weekly testing that we do. The signage again is put out at the public areas, which is basically the Wells College dock area and the little bathing beach that they have there. All the remaining areas, as well as there's a small little area at Little Creek that's often utilized. We have signage put up there. All the remaining areas is privately owned, so we can't put signs up, but what we do is we notify all the owners of all of the properties, as well as those that are within a half mile of the treatment areas, that of the schedule that we'll be doing and the types, and with any information, as well as contact information if they want to talk to us for additional information. Some additional resources, not to go over much of this, but basically, because this is being recorded and for future, there's a lot of really good resources out there that talk about not only the treatments that we're doing, but also the Hydrilla, its potential impacts, and answers a lot of questions. There's also, I will plug, University of Florida Center for Aquatic Invasive Plants podcast series. Jay Farrell has worked with us and helped us, and so have many our Engineering Research Development Center people. Sometimes have been headquartered out of there, and a wonderful resource, excellent, really good information that is put out there, and I would highly recommend checking that out. There's a lot of good information there, not only on Hydrilla, but other aquatic plants, and also just how complex it is or how hard it is to manage these systems, as Michael talked to, where you have multiple different user groups, and how to try to strike a balance between that and to have a really well functioning resource at the same time. And with that, I'll cut it off.
Great, thank you so much, Rich. That's a ton of information, I know, for everyone. So I just want to remind folks that the slides as PDF, in addition to the recording, will be posted on the Cayuga Lake Watershed Network's website and YouTube channel after this session. I know we're going a bit long, so I just want to check in with Mike and Rich about your timeline and your ability to stay a bit longer for the Q&A.
Yeah, that's fine.
No, I'm fine.
Okay, great. There was a super exciting chat going on. I did my best to keep up with all the questions being asked, which were really good, and collect them into themes so that we're not going to necessarily go back through each specific question. But for the ones which weren't covered specifically, or maybe there's opportunity to elaborate a bit, I will sort of start asking those. And I see more are coming in. So in addition to, the questions which we don't get to, or those theme areas which we don't get to during the Q&A, in the past, I think what's worked well is that the network will do some Q&A follow-up in a blog post so that folks can visit this information, and I'll coordinate that with the speakers. So I think one of the themes that was coming through a lot in the chat is that there is concern about the state of aquatic weeds in the northern end of Cayuga Lake. Especially Amy Hazard and John Lorenzo were piping up about this. They are concerned about the entire ecosystem, and are reporting observations that there have been barren areas of aquatic weeds in the northern area of the lake, in areas where they were previously widespread. So could you speak to that a little bit? I know that there's also, there is management going on of aquatic weeds in the northern end of the lake by other agencies. So if other folks would like to pipe into, that's where we can facilitate that. Thanks.
Well, as far as Finger Lake, Prism, DEC, and the core, I believe, correct me if I'm wrong, anyone, but the northernmost extent of any herbicide treatment that has happened over the history of this project is, up around, well, just north of Wells College, but like there hasn't been anything north of, say, Union Springs. Is that accurate, Rich, since that's more of your area?
Yeah, no, the treatments that we're proposing this year are the farthest north that we've done. We've been south of Mackenzie Child since that for all years previously. So that's very accurate.
Yeah, and also as Rich has mentioned, we are doing water sampling incrementally, but even as close as just a half a mile north of the treatment areas, we're at non-detect levels of herbicide. That's less than 1 part per billion. So I guess it would seem very unlikely that the herbicide treatments in the southern ends are causing large patches to disappear from the north end of the lake. But as Liz mentioned, we would need, I guess, to better answer that question, we would need to know where you're finding these voids. And I know everyone out there, I know most people out there fishing have fish finders that are capable of collecting GPS points. So please share that data if you're able to. And if you find more of these voids that you're concerned about, collect that data and send it our way, because that can help, that is not our experience where we're surveying. And it's a massive lake, so we need to know where you're referring to. And it's possible that, as Liz mentioned, there are other agencies. I know some of the soil and water conservation districts are doing like weed harvesting. I believe that's more geared towards like, Eurasian milfoil and such. And that's more of like long-term maintenance to, be able to utilize docks and areas like that. So if anyone has additional information about where that is taking place, and you could overlay that with where you're finding these voids and see if that could potentially be related. Also, obviously, timing of the year, there's a lot less out there now than there will be later. So that kind of, when you do submit this data, if you plan to, having dates and even potentially, water temperature taken off your Lowrance unit or whatever you're using, all that would be great and appreciated.
That's great. Okay, I will connect also with the soil and water conservation districts doing mechanical weed harvesting, and we can share information with the group about those locations and schedules. So in addition, there were some questions about beyond the impacts related to the aquatic plants. There was a good question about how does the presence of hydrilla impact recreation in terms of fishing and boating and navigation. In Cayuga Lake, of course, we know that Cayuga Lake is very deep. And so what is known about the differences and impact, in those shoreline littoral areas and or the deep lake?
So I think Mike hit on this really well earlier, kind of describing, essentially that littoral area, it has to go around the entire lake. And not to say that 100% of that area, and I don't think anybody's claiming that 100% of that area, is a perfectly suitable hydrilla habitat, but theoretically, there is a lot of it is, and just by, extrapolating what could be, come from a large infestation and widespread of hydrilla. I mean, just thinking about people using their docks, the numerous public swimming areas, literally just boating, getting in and out of, the Cayuga Inlet, or getting in and out of, the Cayuga Seneca Canal, navigation up to the Great Lakes, navigation throughout the north end. There are large parts of the lake that could become a monoculture, kind of in the absence of management. And I think that, I think a specific number, a dollar amount hasn't been determined. But, we can base, projections from other areas and what has been experienced in other areas throughout the country. Kind of analogs for what to theoretically expect if there's a widespread infestation. And then again, I think Mike again kind of pointed to that idea of, yes, the open part of the lake at that point, the deeper part, over 20 or so feet, where hydrilla can't reasonably grow. I mean, yes, that is, open, but I mean, you have to get through the weeds to get to that area, right? I mean, I think, yeah, maybe there's, I think that's kind of my 2 cents.
I can jump into the littoral area that we're talking about, or I actually, when I was originally started on this project, had to do an environmental assessment for this, and the littoral area of Cayuga Lake there's 10,700 acres that are less than 18 feet of water in the lake. So although the lake itself is huge and you can use that open water area, like Sam and Mike have both said, it's still a sizable area, 10,700 acres, and it is the path to get to the open water area, as well as most fishermen and most recreators are usually within that 20 to 25 foot area. Yes, there's some that cross and stuff like that, and it is a rather deep lake, but that area tends to be the area where a lot of this recreation actually occurs. Fishing, granted, you have offshore fishing for lakers and stuff like that, but for smallies and some of the pan fishermen and stuff like that, you're concentrated in that shallower water area around these aquatic vegetation beds and stuff like that. So hydrilla can impact those areas just based on how dense it can grow and how much it can change the water quality. At first, it could be a benefit in some cases, creating structure and habitat. Over time, it can actually have the inverse problem and actually start excluding these areas from being really suitable habitat as a result of its growth and the way it can impact the water quality. So.
Thanks, Rich. So
Yep.
I'm just going to reiterate real quick
For
that none of these organizations in this, well, the presenter organizations of this group, no one is spraying the north end of the lake.
Yep.
Not only we're trying to be transparent about all our plans. We don't have even the resources to just go out there and fund a massive secret spraying campaign of the north end of the lake. So yeah, it's not, no official or secret spraying is happening on the north end of the lake. At least not by the DEC, the Corps, or the Finger Lakes president.
And I think I want to just make one point too, that you know, things are changing out there, obviously, but you know, I think there's a good thing. Like I said, you know, this population of hydrilla and what we're doing here is managed, and I think that's part of the other issue. This is not an unchecked population. We're managing this population. We are getting a knock on some of it, keeping it down, trying to keep the native vegetation and that biodiversity that we want. And I mean, there's a pro bass tournament going on right now, and the top fishermen from yesterday caught 28 pounds of smallmouth bass and 5 fish. Their average was over 5 pounds. To be in the top 20 for that tournament yesterday, you had to catch more than 20 pounds of fish. That is outstanding. I mean, that's a nice fishery to have 4+ pound smallmouth bass, and not just one, but a bunch of them. So this system is not completely you know, gone. It's being managed, and I think there are some other things that come into this play as well. There's a lot of concern about the water quality and some of the sediment and harmful algal blooms and things like this. The hydrilla and the aquatic plants are not just the only sole source of that. You also have to look at land use patterns in the watershed itself. Liz talked about that, and the fact that you have sediment control practices, agriculture that applies pesticides and fertilizers to those areas that help bring nutrients in. And in these areas, when you have large rain events and that flush these nutrients into the lakes, it can cause some localized issues in those particular areas. So you know, this is a much more complex issue than what we're just demonstrating. We're just talking about one piece of this puzzle.
Thanks. Yeah, that's one of the major challenges that, you know, our organization and management of the long-term ecological health of the lake involves, right? It's those interacting stresses to the ecosystem, and, you know, including additional invasive species, pollution, issues with runoff, temperature in the lake. It's all really complex. And we want as much good science backing up our understanding of those systems as we can get. So that's always a priority for our organization to understand and share with you folks as it becomes available. I just want to point out one comment from Erin Parazzini from the Seneca County Soil and Water Conservation District, which manages a mechanical harvesting program. And does receive many complaints about excessive aquatic weed growth from residents around the north end of the lake and lake users and the areas which have been referred to, including Cayuga, Red Jacket, and north, specifically around Lower Creek Road. So that is another important point to make. I want to pivot here to Tom Burke's questions. He's asked several about dredging of the Cayuga Inlet and what the plans related to that are, and if you could make any connections to the hydrilla issue, that would be much appreciated.
I've got to say, I don't know. I can't speak in great detail about the dredging in the Cayuga area. I know that dredging was successful at one of our sites, Don's Marina in King Ferry. It was a very, very small contained area where we were able to create a cofferdam, drain it, and dredge it just using a backhoe. So I don't think that's what Tom's referring to and curious about, but is my, you know, the bulk of my understanding of dredging that we've been a part of on the lake has occurred, yeah, at Don's Marina in King Ferry, and that treatment method combined with spot treatments of herbicides has been really successful so far. So perhaps somebody else can speak about the dredging and if it got.
I can jump in here. The Corps, because we actually built the original inlet flood control area that and I believe dredged it originally, and that I've been approached yearly by residents and locals asking about when we're going to dredge again. That project was turned over to the locals, to the city to manage, and I believe in at least I saw some email traffic that there now is discussions to possibly dredge that Cayuga Inlet. And they reached out at least in an email just asking if they were to do the dredging, just exactly what Tom's talking about, how could they potentially do that and benefit the hydrilla, especially removing of some of the tubers and stuff like that. As you said, Sam, it was done effectively at Don's Marina. It's also, they did do a small dredging in Fall Creek as well, and that seems to have been effective as well with the application afterwards to make sure we cleaned up any areas that couldn't. I think the dredging, if done outside of the normal growing season and done in a way so we don't spread tubers or potential fragments, that it definitely could be beneficial. The question is whether the dredger would be able to do it at that time of year. The dredging projects you and I are referring to at Fall Creek and at Don's Marina were very small projects that were able to be done with a hoe. The Cayuga Inlet is going to be a commercial operation with either a clamshell or with a hydraulic suction dredge. So it's a much bigger operation and much more expensive. So depending on how they do that, yes, that could be very effective. I think there's discussions right now, but I've heard nothing concrete or anything. And you know, and it's a local issue that would be dealt with unless there's some change and they pull the Corps in to actually help out with the planning and dredging of that. But right now, that's all on the locals, and that's all I know for now, right now, as to what's going on with that.
Great, thanks for the follow-up on that. Let's see, much to sort through here.
While you're looking through that, I also just want to say, you know, generally that, you know, I don't think anyone, well, aside, you know, there's obviously been some concerns listed here about patches of vegetation disappearing on the north end of the lake. And that, you know, is a justifiable concern for sure. I think overall lake-wide, you know, people have not yet had to experience any of the ecological or economic or recreational impacts that may otherwise be being experienced had this program never started in the first place. I know, you know, I'm obviously newer on the project as of last year, but, you know, I've heard Rich talk about, you know, the original large patches that he was finding over in kind of the general Aurora area. And since then, you know, the general biomass of Hydrilla itself has been knocked back significantly to where it's not creating, you know, we're not experiencing the impacts of these large monocultures or loss of biodiversity or loss to recreational opportunities. And just also that, you know, we do care about all these things. We do try to balance the needs of all these different interest groups and stakeholders of the lake. You know, the DEC, for example, you know, we have our own fisheries department. They're obviously all people that love fishing and fisheries and got into that field because of that. And some people may have the view that like, oh, well, the DEC is just issuing itself its own permits or something like that. Having gone through this permitting process, I can tell you that, you know, it was very difficult and there are a lot of checks and balances internally. My first draft of my permits for this year had a larger treatment area for sheldrake, and the fisheries, the Department of Fisheries kicked it back and wanted me to scale it back, and provided their input, and then I did scale it back given their recommendations and concerns. They all get a chance to look at and have their say before any of these permits go forward. So they're all those internal checks and balances. But yeah, just wanted to say that real quick.
Thanks, Mike. So I think we're approaching 11:45. It's definitely been a power half hour of Q&A. Rich or Sam, do either of you want to add any last words here for a wrap up before we move on and get ready to post this and share the slides and address any follow-up questions in writing?
No, I think I'll reiterate what Michael said, and that is that, you know, we've been transparent all along. We're trying to be as transparent as possible. We follow all the regulations and rules, and we do have a large number of individuals that review these treatment plans that have a say in them, and we are really trying to pinpoint just hydrilla and reduce any impacts and keep this biodiversity out there. The only last thing I will say is although we are centered in Buffalo, there's been some questions about, you know, how often we're out on the lake or how often these crews are out there and stuff like that. I know Michael's out there an awful lot, even though he just started this last year. Finger Lakes Prism is out there all summer doing their work, and the Corps is there at least once a week starting in May, June, all the way through to October. So we're out there at least a week every month, and sometimes even more. And that's been since we started out there in 2016 doing this. So we're pretty familiar with the area and not nearly as much as some that are on this call that live there and recreate there all the time, but we are pretty aware of that. And if you see us at the boat launch or you see us driving by, don't be afraid to flag us down, because we talk to the locals and we talk to the fishermen all the time when we're there answering questions and getting good information. And like Michael also said, you know, if there is some impacts to aquatic vegetation going on outside of our area, and it's a result of something that is you know, it's outside of what we're doing, but if it's something else, it's definitely something that we want to know, because we are looking at this as an overall management plan of all these areas and how it interfaces with this to get a much more healthier ecosystem. So understanding why potentially there's some loss of vegetation in some areas that are outside of our treatment areas that we're not monitoring is definitely something that would be useful to know, and something that someone probably would look into pretty quick. So.
And
Yeah,
also, sorry, Sam, I was just going to say that, you know, the DEC also has the Finger Lakes Hub Group, and they focus a lot more on water quality specifically, as well as harmful algal blooms and that kind of thing. So please, you know, specifically with harmful algal bloom questions and inquiries, I would say direct that messaging to them, because that is one of their, you know, they have a much narrower focus on that, as well as water quality in general, and have long-term data sets. And keep in mind, you know, there are other non-source point factors, like, you know, there's all stormwater runoff and all that kind of stuff ends up finding its way to the lake. So, you know, septic systems, farming practices, there are more variables going on here than just herbicide in the southern half of the lake. And, you know, these herbicides are specifically designed for aquatic use, as opposed to some of these other third-party sources. And, you know, I'm not quoting any specific information with that. I'm not trying to blame anyone else. I'm just saying there are a lot of other factors to consider. So yeah, Finger Lakes Hub, you can find their contact info immediately, or easily online, I should say. But they can answer more water quality and harmful algal bloom questions.
Yeah, I just wanted to reiterate what Rich and Mike said, kind of, at the end of the day, if you're going back to the vision and mission of the Finger Lakes Institute and the Prism, we have, the best interests of the ecosystems and the water quality in mind, of course. But like I grew up in the Finger Lakes. My family's livelihood literally depended on tourism in the Finger Lakes. So we do also care about the communities that are using these resources as well. I mean, I think again, going back to the the DEC and the Army Corps as public entities, they are interested in the people that use these resources. So I think that's always something to keep in mind, and just wanted to say thanks again to everybody for joining and for lively discussion.